Hello. This is the second part of our talking on fossil fuels and alternative energy sources. So I made a video where I talked about why do we use fossil fuels? Everybody knows fossil fuels are bad, fossil fuels are terrible, they pollute the air, and we're going to run out of them. So then the question is, why use them? And one answer is they're incredibly good at what they do. They provide the energy that we need to run things, and they've served us well for hundreds of years. But the truth is, we are going to run out of them, and they do cause a great deal of pollution. There are things we didn't understand back in the day. We knew that when you produce a lot of smoke and soot, it's bad for your lungs. People figured that out pretty quickly. What they didn't realize was that this can actually be changing the ecosystem of the earth, causing changes in climate, even subtle changes. Even just a few degrees can change weather patterns, and that can create a very disruptive event. So we need energy. We have fossil fuels. We don't want to use them. We're going to need to replace them. So this is where the alternative energy sources come into play. And there are several. I'm going to go through each one of them. And once again, got to admit, there is no free lunch. Every energy source has advantages and disadvantages. There's a reason why no one of them is likely to be the energy source of the future. In all likelihood, we will still be using fossil fuels for some things, making plastics, for example. But if we can reduce our reliance on them, it would be best for the environment, best for humanity. So let's look at some of the ones that might take its place, or at least take part of its place. First one is probably the oldest energy source, biomass. Simply burning wood provided heat, provided light. You can make an engine run on wood. It's not easy. You're going to be throwing a lot of wood into the fire, but there's things besides wood that we can use. We can make ethanol, alcohol. Some of the same plants that we use to eat, we can also make into alcohol. And ethanol is now found in most gasoline. What's good about it? It's renewable. We can plant a crop, harvest it, turn it into ethanol, plant it again next year. It's no different than growing food. And there's the potential problem. Plants that you're growing for energy are plants that you're not growing for food. And as much as we do need energy, you can't live for very long without food. They're obviously not going to take all the farms and turn them into ethanol production, but they will some, and that's going to keep the price of food up at a certain level. For us in the United States, that may not be a problem. For other places, it could be. There is a trade-off. Again, land, and if you need to grow more plants for energy, you're going to need to make more farmland. And making farmland is an ecologically disruptive thing. You're cutting down trees, you're clearing out natural grass, and you're planting your crops. And burning biomass does put carbon dioxide in the atmosphere. The advantage of it over fossil fuels seems to be almost entirely that it is renewable, where fossil fuels are not renewable. In terms of greenhouse gases, it doesn't seem like this is much of a solution. Hydroelectric power. This is damming up a river. So you're creating a giant lake where once there was a river. You put holes in the dam, water goes running through those holes, and as it does, it spins a turbine. Now, energy has a cool characteristic. You can take one form of energy and turn it into another. The energy of motion is kinetic energy. So as this water, under a great deal of pressure, we've got this big lake pushing against this dam. We open up a hole, water comes shooting out, spins those turbines. That's now kinetic energy. We can take that kinetic energy and turn it into electricity. That's what a generator does. Send that electricity to people. Well, this sounds pretty good. I mean, the water never runs out. Every time it rains, every time the snow melts, that water comes down. What used to be the river goes into the lake. We let it out as much as we want. I wouldn't say it's free. It costs a lot to build a dam, and it has to be maintained, but they will last a very long time and replace the moving parts. You've got a pretty cheap form of energy, and one that is not requiring you to dig up the ground or do any of those other things. There's no smoke. There's no greenhouse gases. Sounds great. And it is great as long as you don't care about the river, because the river has been destroyed. You've taken this river, a very important part of any ecosystem, a very important part of the livelihood of many people. Folks live on that river. Almost everyone lives near a water source. That's why cities and towns are built where they were. And that's gone now. Fish are going to have a hard time going up the river to spawn. It destroyed the salmon industry. It's been so ecologically disruptive that many dams have actually been destroyed. But now maybe we need to go back and rethink that. As much as it's heartbreaking to hurt a river, if we're talking about a global problem, like greenhouse gases and global warming, maybe that's the trade-off we have to make. And once again, we're left with there's no free lunch. We're making a trade-off here, stopping global warming, or at least mitigating it by damaging another ecosystem. It'd be nice if we could solve both, but that seems to be not in the cards. Now, I've already mentioned nuclear power. Nuclear power is probably not proper to say it's renewable because we are using a natural resource, uranium. However, the amounts of uranium that you use are so small that it's inconceivable. Even if we went strictly nuclear power, I don't think we'd run out of uranium anytime soon. There is a lot of radioactive material. There are even ways of using the radioactive material produced in nuclear power plants to run other nuclear power plants. So you can get a phenomenal amount of energy out of nuclear fission, which again is splitting atoms. You split an atom, it breaks into pieces. Those pieces hit other atoms, cause more breaking. Every time an atom splits, it releases a little tiny bit of energy. Not very much, but atoms are so small that once you start this process and if it goes out of control, you have a nuclear bomb. We control it. So instead of everything just going crazy, it creates a great deal of heat, which is used to turn water into steam. The steam shoots through pipes, makes a turbine spin, just like with the waterfall, with the dam, and we get electricity. That smoke you see coming out of the towers of a nuclear power plant is not really smoke. It's steam, just a cloud, not going to hurt the environment at all. So it seems like a perfect solution, but it's the one that's probably the most controversial. People are afraid of nuclear power. When they hear nuclear power, they think nuclear bombs, or they think legitimately, what happens if something goes wrong in a nuclear power plant? A coal factory blows up, many people die, but that's about it. If an oil refinery blows up, people die. If a nuclear power plant melts down, if it breaks apart, if terrorists attack it or a natural disaster hits it and everything goes wrong, you've probably contaminated an area of hundreds of miles that can never be lived in again, not in any foreseeable future, thousands of years. That's a scary thought because obviously we're going to build power plants near places that need it, cities. So if something goes wrong, you've contaminated an area that's not out in the middle of a desert somewhere. People ask, why don't we build them in the middle of deserts? You need to be able to get the energy from the power plant to the people who need it. The further away you are, the less efficient that's going to be. There was a while where they were building a lot of nuclear power plants. We had the disaster at Chernobyl, where a Russian power plant melted down. There was a lot of human error. There was another disaster in Japan when a tsunami hit it. Folks there didn't do anything wrong, but that tsunami is a natural disaster that's pretty hard to stop. And people think, well, if all the power plants were nuclear power plants, we'd probably be seeing more and more of these kinds of accidents. And can we afford that? And it's really too bad because it is a very good energy source. There is an additional problem I should add, which is at the end of the day, you don't produce any air pollution, you don't produce any water pollution, but you do produce a very radioactive waste. And you have to come up with some way of disposing of it safely. Well, there is no safe way to dispose of it. Even, people say, put it on a rocket and send it to the sun. Well, rockets blow up as they're going up. Sometimes 1 out of 100, 1 out of 1,000. If a rocket full of radioactive waste blew up, it would be the greatest man-made disaster in history. So until anyone ever figures out a way to safely dispose of the waste, I don't know that nuclear power can ever become the dominant energy source of the future. Geothermal is an interesting energy source. The center of the Earth is very hot, and that heat rises to the surface, produces plate tectonics, earthquakes, volcanoes. That's a lot of energy. And we can take any energy and turn it into the energy we want. We can take heat and turn it into electricity very easily. So if you've got a place where the magma is not on the surface, that would be a volcano and not a good place for a power plant, but near the surface, not 7, 20, 30 miles down, but a little closer, enough that you have hot springs. The groundwater gets so hot it blows up in the air. We're talking Yellowstone Park. We can take that heat, we can take that energy, send water down there, let it get really hot, turns to steam, goes through the pipe, spins the turbine, electricity. Doesn't seem like there should be any problem with this. There's no air pollution, there's no water pollution. So what's the problem? The problem is basically there aren't too many places on Earth that fit that description. Yellowstone is a good one. Iceland, a good one. I don't know that Sanford would be a good one. The magma in Sanford is pretty far down. It would be very expensive, maybe not even possible, to build a plant that could efficiently tap that energy source that's so far away. Similarly, tidal energy. The tides come in, the tides go out. They're moving. Kinetic energy. We can turn it into electricity. But that can only be done where you're exposed to the tides. Ocean. That's some of the most expensive land on Earth. And it's in the ocean. You're talking about pretty delicate machinery that has to be in salt water, has to be able to survive storms. I don't know that yet we're there. There's a lot of interesting proposals out there of different ways that we can use the tides to generate electricity. I don't know that it will ever be more than a few percentages of the total amount of energy that's used, but a little here, a little there, it adds up. The big one, the one that probably gets the most attention, solar energy. The sun is obviously the ultimate source of energy. It's the thing that we ourselves run on. The heat coming off your body is solar energy that's been converted into chemicals and then converted into kinetic energy and thermal energy coming off your body. So the sun provides unimaginable amounts of energy. If we could capture just a few percentages of what the sun gives us every day, we could easily run every city, every town, every village on Earth. But the problem is capturing that. There are a number of ways of doing this. Some of them passive, where you simply put a window in your house that allows the sun to come in a certain way. You don't need a light there. Some of them are more direct. Solar cells take solar energy, convert it into electricity. The problem with it, it's expensive. It's getting cheaper, and hopefully with continual technological advances, we will be able to get it cheaper still, to the point where it's affordable to the average person. Right now, you have to be willing to invest a considerable amount of money to make your house totally go solar and not be reliant on other sources of energy. Certainly out of the reach of many people in most parts of the world. But if we can get that cost down, perhaps improve battery capacity so that even on days where the sun isn't producing enough energy through the clouds to get to us, that we can still run things. Solar has a real future, but there are limitations. It's hard to imagine a solar-powered car. Cars simply aren't big enough to capture enough sunlight. The amount of sun hitting them is too small to give us energy that could actually make something as large as a car move. They've made solar-powered cars, but they're extremely limited in how fast they can go and how much they can carry. Now, there is one place where solar energy is pretty easy to use because there's so much of it, and that's the desert. No clouds. Obviously, you can't get solar power at night, but every day is usually a cloudless, bright day with the sun beating down. You can produce a great deal of energy by building these mirrors in the desert that are focusing the energy into one spot. Problem is, as we said before, not too many people live in the desert. So whatever energy you make is going to have to be transported pretty far away. Wind energy is something like solar energy. They're expensive to make. These windmills are pretty expensive. Windmills are constantly moving. That creates a lot of wear and tear. So you have to factor in the cost of repairing them. People don't like living near them because they make a lot of noise, and they are destroying the bird population. Birds do not know how to deal with these giant windmills. That may be the unfortunate trade-off that we have for getting cheap energy. Wind energy works best where there's a lot of wind. It has to be pretty reliable. There are a few places like that, the tops of mountains and beaches. Beaches, as I said, are the most expensive land available, and people who live there don't want giant windmills there. You also have to take into account that the wind can sometimes get destructively strong, and you need to be able to take apart your windmills when a hurricane or even just a good tropical storm is heading your way. And the tops of mountains, a good place for them, but who lives there? So, in conclusion, it's good that we are now beginning to look at these alternative energy sources, because we're not yet at the point where we desperately have to switch over, but we will get to that point. And if we're smart, we'll do that before we get to that point, hopefully long before we get to that point. There are new technologies still being invented that make these alternative energy sources more efficient, more useful. There are technologies that have yet to be invented that could solve the problem entirely, like nuclear fusion, doing what the sun does and producing a near limitless supply of energy with very little material and no real pollution. But that has not been invented yet, and you can't really depend on something that hasn't been invented yet. It might not have been invented because it can't be invented, at least not in the foreseeable future. So we need to continue to explore these and try to improve them. Hopefully in your lifetime, you will see more and more of our total energy needs being supplied by alternative energy sources, with the ultimate goal to get as free from fossil fuels as possible. Thank you.